Okay, so this is the second video talking about how to evaluate the F ratio. So I've again included this diagram here, which is called the theoretical sampling distribution of F. This is the case when the null hypothesis is true. And this chart, the horizontal axis is possible values of F ranging from 0 to infinity, and the vertical axis is frequency or probability ranging from 0 to either 1 or infinity, depending on whether it's frequency or probability. All right, again, this is when the null hypothesis is true. And let's remember what the null hypothesis is. The null hypothesis says there's no treatment effect. So when there's no treatment effect, it means there's nothing going on. And when there's nothing going on, we expect most of the values of F are going to be small. Okay, so how is it that we use this theoretical sampling distribution when we're evaluating the F ratio? Well, what we're going to do is we're going to just kind of eyeball this right here. We're going to draw this line all the way through the curve right about there. And if you think about where you're going to draw this line, you want to draw it in the spot where about 5% of the area under the curve is to the right. And then, of course, that would mean 95% of the area under the curve is to the left. Why is it that we choose that point? Well, as I said in the last video, we have to decide for ourselves how much error we're willing to accept. And in psychology, we're generally willing to accept a 5% chance of error. So that's where we're going to draw this line, at the point where 5% of the time the values are over here and 95% of the time the values are over here. And this point on the curve has a very special name. It's called the critical value of F, which we often just call the critical F. All right? So once we've drawn that, once we have found the critical value of F, and it's really easy to do it. I'm going to show you how to do it in the next video. We're going to use a chart that's in the back of the book, and also a chart that there's another copy of the chart that I posted on our Blackboard site. Once we find the critical value of F, we are going to go back to our ANOVA summary table, and we are going to find our observed F, which is the F we calculated when we went through all the steps. And we're also going to plot that F on this line. So it's possible that F is going to be smaller than the critical F. It's possible that the F is going to be larger than the critical F. It really doesn't matter, but we're going to plot it where it is on the line. All right, so let's assume for a second that our critical F is 3 and our observed F is 1. Our observed F is going to go over here. If our critical F is 3 and our observed F is 10, then our observed F is going to go to the right. All right? Once we do that, then it's time to make some decisions. So this is how we make the decisions. If our observed F is greater than or equal to our critical F. So if when we plot our observed F, it's to the right of this line, we are going to reject our null hypothesis. Now let's think about what that means. Our null hypothesis says there's no treatment effect. If we reject that statement, it's a double negative, but if we reject that statement, what it means is that there is a treatment effect. So our conclusion then is there is a treatment effect. All right, thinking about the different ways that we wrote the null hypothesis, let's talk about the next way. So if there is a treatment effect, what that means is there's something going on. So what does that mean about the means? It means the means are not equal. And again, what it really means when we reject the null hypothesis, it means there's something going on. So thinking about our study, it might mean noise affects memory or color affects happiness. Now let's think for a moment about what would happen if our observed F fell to the left of this line. So if our observed F is smaller than the critical F, we're going to make a different decision. We are going to fail to reject our null hypothesis. And this language is very specific. We either reject or fail to reject our null hypothesis. We don't accept, we either reject or fail to reject. And if we fail to reject our null hypothesis, the conclusion is the opposite of what it is when we reject. If we fail to reject, what that means is there is no treatment effect. And it also means the means are equal. Thinking about what it means in practical terms, it means there's nothing going on. So depending on our study, it might mean noise doesn't affect memory or color doesn't affect happiness. Okay, so again, this probably seems a little abstract at this point. Hopefully it's getting a little more concrete. In the next video, it's going to get even more concrete because in the next video, I'm going to show you specifically what you need to do, very practically speaking, to evaluate your F ratio. But basically, in a nutshell, you're going to draw this curve. You are going to find and map your critical F. And honestly, from my perspective, it doesn't matter where you draw the line. I'm not going to be measuring it. But when we think about where the line goes, it really wants to go, you really want to put it almost to the right, the far right of the curve. And we're putting it in the spot where the world is divided into 5 and 95%. Once you put your critical F on here, then you're going to go back to your ANOVA summary table and you're going to put your observed F or your calculated F on the chart as well. And then all you're going to do is compare those two numbers. You're going to compare your critical to your observed. If your observed is greater than your critical, so if your observed falls over here, you are going to reject your null hypothesis and conclude that there is a treatment effect, the means are not equal, and something is going on. If your observed F falls to the left of your critical F, if it's smaller than your critical F, you fail to reject the null hypothesis and conclude there is no treatment effect. The means are equal and there's nothing going on.